Alright, next example. Okay, next example is related to Coriolis force. Okay, in this example, I have a wire. This wire, a bead is sliding without friction on the wire. This is the bead. This bead is sliding without friction along the wire. It is a very massless wire, so that I am not considering its weight. Okay, so this is the R direction, and it is rotate about its x-axis with an angular velocity omega. Right, this is the problem. Okay, so what I want to know is what is the force exerted by the wire on the bead. Okay, what is the force exerted by the wire on the bead? So that is what I want to know. Okay, how to do this problem? Okay, so for that I am analyzing it in a different way. Okay, here also I assume I am in the rotating frame. Okay, so it is similar to the last problem. In the last problem also I assume I am in the bucket, so bucket is the rotating frame. Okay, so here also I assume I am in the rotating frame, so that is a little easy to solve that. In the rotating frame I can consider the fictitious force and so on, so things that you know. Okay, so if I look from the top on this figure, what I am seeing is this one. Okay, this one. Okay, from the top, this is the 0 is the z axis upwards, and it is rotate along this direction counterclockwise. Okay, so the force diagram will be this one, the fictitious force. Sorry, this is the centrifugal force. Here the fictitious force is actually the centrifugal force. Okay, centrifugal force also is a fictitious force. It arises in the non-inertial frame. Okay, F centrifugal, and here the Coriolis force. Coriolis force is perpendicular to W omega Coriolis force and the normal. Okay, right. So the equation will be, there are two equations. So F centrifugal minus this direction, the radial velocity mr double dot. Okay, F centrifugal minus mr double dot is equal to 0, and n minus F Coriolis is equal to 0. These are the two equations. This is well known. It's positive, this is positive, these two are negative. Okay, that's good. Okay, if you take the first equation, F centrifugal, what is F centrifugal, is equal to m omega square. So therefore m omega square r minus mr double dot is equal to 0. I just multiply with a minus, so it will be mr double dot minus m omega square r equal to 0. Okay, this is a general equation. Okay, you can cancel the m, so it will be r double dot minus omega square r equal to 0. This is an equation of this form, d square y by dt square. So this equation, d square y by dt square minus omega square y equal to 0. Right? So this is a general equation. Actually in physics there are different equations. These two equations are of particular importance. D square y by t square plus omega square y equal to 0. What is that solution? The solution is y is equal to a e raised to I omega t plus b e raised to minus I omega t. It is a sinusoidal solution. It is an oscillating solution. That is a general solution. If the plus is reversed by minus, that is d square by dt square minus omega square y equal to 0, then its general solution is y is equal to a e raised to omega t plus b e raised to minus omega t. That is an asymptotic solution, not oscillating. That is a difference. So here we have r double dot minus omega square r equal to 0. So its solution will be asymptotic. So general solution r is equal to a e raised to omega t plus b e raised to minus omega t. That is a relation. Okay, so if we take the second equation, n minus F Coriolis is equal to 0, that is n is equal to F Coriolis is, that is equal to F Coriolis is 2m r dot omega. Okay, why it is? So these are 90 degree. Okay, therefore sin 90 is 1. Therefore it is 2m r dot omega. So 2m omega into r dot. This is r, first differential of r, that is omega into a raised to omega t plus minus omega b raised to minus omega t, that is equal to 2m omega square a raised to omega t minus b raised to minus omega t. This is the force exerted by the wire on the bead, right? So that was also a easy problem. So the solving problem in rotating frame is sometimes little easy.